So today's lesson, we're continuing in our Module 7, which is about circles, and here we are going to be talking about sectors and the area of a sector. So our goal today is to use the properties of circles to find the area of a sector. So first I need to know what a sector is, and then I need to figure out how do I find the area of it. So because we're dealing with area, we're going to be talking about two-dimensional things, so we're always going to be using units squared. So this is what your exit ticket's going to look like. So by the end of this lesson, you should be able to find the area of shaded regions given different situations. So go ahead and just look over this and see what you know and see what you need to know. Alright, so let's just talk about pizza for a minute. You are sharing a pizza with a friend. The pizza is cut into 12 slices. The diameter of the pizza is 16 inches. How much pizza does each slice contain? So how much pizza is on there? So see what you can figure out. Use the information that you know and your background knowledge and see how far you can get. Alright, so we said one of the first things we need to know is what a sector is. So a sector is a slice of the circle that is cut out. So I think about sect meaning cut. So sector is a piece that's been cut out. So if I take this whole circle, this shaded area is the part that's been cut out, so that is the sector. The area of the sector is a fractional part of the area of the whole circle. So we talked about this last week with the area or the length of an arc. The arc, which is the outside part, this is like the circumference, is a part of the entire circumference. So now we're talking about the area on the inside, so a sector is a part of the whole area. So the area of a sector is found by using the following formula. So last week we talked about the arc length is a percentage of the entire circumference. Well, now we're using the exact same idea. It is a percent of the total area. So let's think about how we found the percent. So if it's the entire circle, it's all 360 degrees. So that would be 360 degrees out of 360 degrees. Well, here I have a specific angle of that 360 degrees. So to find the percent, I took my angle over 360 because that told me percent. The word of in math means to multiply. And we find the area of a circle by using the formula pi r squared. So what this will do is this will give me the entire area of the circle, and then this gives me the percentage that's been cut out. So it's just like our previous lesson, but now we're using area instead of circumference. Alright, so for these examples, it's asking me to find the area of the shaded sector. So I'm going to be using my guiding questions of what measurement am I finding? So am I looking for area or circumference? What is the area or circumference of the circle? What percent of the circle is shaded, and how can I find the area of the shaded region? Okay, so when I look at this, I know I'm finding area, so all of these will be, that first question is area, and I know I'm using the formula pi r squared for the area of a circle. So when I look at number 1, what part is shaded? I know that the arc is 72 degrees, okay? So if the arc is 72 degrees, then its central angle is also 72 degrees. So what percent of the area is shaded? It is 72 out of the 360 degrees that exist in a circle. Okay? And I'm going to say what percent of, so I'm going to multiply the whole circle's area. So the area of the circle is pi, and I see that 15 is my radius, so 15 squared. Alright, so I'm going to calculate what percent that is. So 72 divided by 360, and that gives me 0.2. So 20% of the circle is shaded. So that would be 20% of 15 squared, so 225 pi. So the whole area is 225 pi, and I want 20% of that. So in some cases they want you to leave it in terms of pi, and other times they want you to use a rounded. If they don't give you that information, if they don't tell you specifically, then I would use the rounded information. But I always like to calculate what it is in pi and then what it is in terms of the decimal. So what I'm going to do is I'm going to multiply 0.2 times 225 And so that gives me 45 pi. So the area of the sector is 45 pi, and then I'm going to take 45 and times it by pi, and that gives me 141.37, and it's measured in centimeters squared. Alright, so let's just review what we did really quickly. So the first thing we did is we set up our fraction. So we used the arc, which gave me the central angle, so I can use either one of those, out of the 360 degrees that exist in a circle, and I multiplied that by the area of the whole circle. And so I found out that this shaded region is 20% of the whole area, which is 225 pi, and then I calculated what is it in terms of pi, and then what is it in terms of a decimal. Alright, let's look at number 2. So the first thing I want you to do is I want you to label, see if you can set up your equation. Alright, so you should have gotten that it's 45 degrees out of 360 degrees, so the shaded part is that fraction of the whole area. And the area is pi r squared, and I see that my radius is 18. Alright, go ahead and calculate the percent. So find out what percent of the area is shaded. Alright, so I found that 45 out of 360 is 12.5%, or 0.125. So I'm going to multiply that by, let's simplify this in terms of pi. So I'm going to say 18 squared, and I get 324 pi. Alright, so go ahead and find the area. See if you can calculate the area in terms of pi. So I got that 324 pi times 12.5% is 40.5 pi. So the area of that shaded region is 40.5 pi. And now see if you can calculate the area in terms of the sector in terms of a decimal. So you should have gotten 127.23 yards squared. Alright, if you feel comfortable with this process, I'd like you to try 3, 4, and 5 on your own. So for number 3, you should have gotten 88.49 meters squared, and in terms of pi, 28.17 pi. So remember on this one, it's really important that you keep the actual decimal in your calculator, and when you're multiplying or dividing, that you use that value. So we're using that second answer button. So if you got that, go ahead and move on to number 4. If you didn't, I'll go through that process right now. Alright, so the first thing I did was I recognized that the shaded region didn't have an arc measure or a central angle. So I looked and I saw that the area next to it, the arc next to it, was 120 degrees. So I noticed that this was a diameter, which I know a diameter is 180 degrees, so I calculated the area of the sector is 180 minus 120, which gives me 60 degrees. So I know that the area of the sector is going to be 60 out of 360, okay? And then I needed to find pi r squared. Well, r is the radius, which goes from the middle out. I noticed that the diameter was 26, so that meant the radius is 13. So I went and plugged those in, so 60 out of 360 degrees times pi r squared. And I calculated this. This gave me a repeating decimal, so that's why I went out to 4 decimal places. And then I said 13 squared is 169. And I did this math using the true decimal value. So I didn't use the rounded. I went ahead and 60 divided by 360 in my calculator gave me that long decimal, and then I multiplied that by 169. And that's how I got 28.17 pi. And then I just did 28.17, that true value, times pi. So I used my answer that was already stored in the calculator, and I got 88.49 meters squared. So for number 4, I ended up with my pi value being 12 pi and my final answer being 37.70 feet. So if you got that, you can go ahead and move on to number 5. If you didn't, I will explain now. So the first thing I noticed is that my shaded region is most of the circle. So I knew it was going to be over half of the circle. And it doesn't give me an arc measure or a central angle measure, but I did notice that the piece that wasn't cut out was 90 degrees. So I said, okay, I know 360 minus the 90 that isn't cut out gives me 270. So the area of my sector is going to be 270 degrees of 360. So I set up my fraction, and it's going to be that fraction of the total area. So the total area is pi r squared. So when I did this in the calculator, I know that that is 0.75. Some of you may have been able to recognize that if I cut this circle into 4 equal parts, or fourths. Each one is going to be 90 degrees. So I can see that this is actually 3/4 of, so you could have gotten here without doing that math, of pi r squared. And so I did 4 squared is 16. So I multiplied 75 times 16, so, or 0.75 times 16, and that gives me 12 pi. And then I just did 12 times pi, and I got 37.70 feet squared. And the reason I went to 70 is because in the calculator it was 0.699, so the 9 tells the 69 to become 70. All right, go ahead and try number 5. Number 5, I ended up with 56 pi, or 175.93 centimeters squared. So if you got that, you can go ahead and move on. If not, I will walk you through it. So when I look at this shaded region, I know that it's over 50%, and it's almost the whole thing. So I noticed that the piece that wasn't cut out was 45 degrees. So I said, okay, all 360 degrees minus the 45 that isn't cut out leaves me with 315 degrees. So this central angle is 315. So I set 315 over 360 to find the percent of the area that is shaded, and that gave me 87.5% of the total area, and the total area is pi r squared, and I had to get the radius as 8 because the diameter is 16. So 8 squared is 64. So I did 87.5% of 64, and I got 56 pi, and then I multiplied those together and got 175.93 centimeters squared. So what I'd like you to do right now is come back to this pizza problem and see if you can get a correct answer if you didn't before. So I ended up with 16.76 inches squared for one slice of pizza. And this is how I thought through that. So I know that how much pizza is a question about area. So I want to know how much pizza is each slice. So how much is on one piece? So the first thing I did is I labeled my diameter because it tells me that the diameter is 16. So I said, okay, I know the radius is 8. So I found the total area, and this isn't the only way you can solve this problem, but I found the total area of the pizza by doing pi r squared. So 64 pi is the total area. And then I know the pizza is cut into 12 slices. So that means it's being divided into 12 pieces evenly. So I did the total area divided by 12, and I got 16.76 square inches. Alright, so for this next part of the lesson, we're going to be finding the area of the shaded region, and it's going to be made up of multiple shapes. So we're going to be dealing with circles, squares, triangles, and sectors, mostly in this. So the questions I'm going to use as I think through this process is, first, what shapes make up the figure? So for instance, when I look at this example right here, I see a circle and I see a square. And I know it's a square because both sides are equal. All sides are equal. So what shapes make it up? A circle and a square. What expression could represent the shaded region? So when I look at the shaded region, I really see that it's going to be the area of the square minus the area of the circle. So the area of the square would be if this piece wasn't taken out, and it'd be the whole thing, but then I'm taking out this perfect circle that's been cut out. So that is the expression that could represent the shaded region. Then what is the area of each shape? So I'm going to calculate the area of the square first. And so the area of a square is just base times height, which is 10 times 10, which is 100. Okay, and then I'm going to calculate the area of the circle. And the area of a circle is pi r squared, okay? So I know that the pi r squared, r represents the radius. Well, if I think about the diameter is 10, because the side of the square is 10, and it goes from one side to the other. So the radius is going to be 5. So the area of the circle is going to be pi times 5 squared, which is 25 pi. And for the sake of this, until I'm completely done, I'm not going to round or do any calculating with decimals until the very end. So I'm going to leave it as 25 pi. So I'm going to go back to my original equation. So what is the area? I found what is the area of each shape. So what's the area of the shaded region? I'm going to go back to this right here, and I'm going to plug it in. So the area of the square minus the area of the circle. Okay, well I found the area of the square was 100 minus the area of the circle, which is 25 pi. And so I'm literally just going to type that into my calculator. 100 minus 25 pi, and I get 21.46. 6, and that is inches squared. So that's how we do it. So let's just do a quick review. So the first thing I did is I found out what shapes are represented. So the shapes that I saw are a square and a circle. And then I said what expression could represent the shaded region. So this shaded area in each of these corners is the area of the square minus the area of the circle. And then what is the area of each of those shapes? So the area of the square was 10 times 10, which is 100. And then the area of the circle was pi r squared, and I found the radius because the whole diameter is 10, and so the radius is 5. And then I left it in terms of pi because I don't want to round until the very end. So what is the area of the shaded region? It's the square minus the circle, so 100 minus 25 pi. So when I look at number 7, I'm going to go through those questions again. So what shapes make up the shaded region? Okay, well, I see that it is going to be, I see a triangle right here. And then I also see a sector, because a sector is a piece of the circle that has been cut out. So the sector goes along the edge of the circle, and so it's like a piece of pie. So what equation or expression could represent the shaded region? So the area of the shaded region is going to equal the area of the sector, because that's the shaded part, minus the area of that triangle. Okay, so I just looked at it and I saw if I took the sector, if the whole thing was filled in, it'd be the area of the sector, but I'm subtracting out that triangle, and that will give me the area of the shaded region. So my next question is, what is the area of each shape? So I'm going to find the area of the sector first. Okay, well, we did that in the beginning of this lesson. The area of a sector is the percentage of the area of the circle. So when I look at this, I see that the sector is a 90-degree angle. So really, it's 1/4 of the whole circle, because it's 90 out of 360. So 90 out of 360 times pi r squared, because that's the area of a sector. So I am just going to multiply 90 divided by 360, and I get 0.25. And then I'm going to say 0.25 of 100 pi, and I got 100 by 10 squared. And so when I do 1/4 of 100, I get 25 pi. And I'm going to leave it in terms of pi. So the area of the sector is 25 pi. So now I have to find the area of the triangle. Okay? Well, area of a triangle is 1/2 base times height, remember? But that has to be a right angle. So when I look at this right here, I do see a right angle, so the base is 10 and the height is 10. So it's going to be 10 times 10 divided by 2, which is 50. Okay? So now I'm going to go back, and what is the area of the shaded region? Well, the area of the shaded is the area of the sector, which is 25 pi, minus the area of the triangle, which is 50. And when I type that in, 25 pi minus 50, I get 28.54 centimeters squared. Alright, so the figure shows two circles. The bigger circle has its center at O and has a diameter of 32 centimeters, and the smaller circle passes through O and touches the bigger circle. So let's go ahead and let's label what we know. So I know that the bigger circle has a diameter of 32 centimeters. So if I think about that the diameter is 32, then that means the radius of the big one is 16. Because 32 divided by 2 gives me 16. Okay, the smaller circle passes through O. So that tells me that's important, because that tells me that its diameter, right, if it goes through O and goes to the center, that means that this whole length is 16. Because a radius is the distance from the center to the edge, no matter where I go. So from the center to the edge here gives me 16. So that's going to make the radius of the smaller circle 8 for the radius. Okay? So go ahead and see if you can answer the first two questions. So what shapes make up the figure, and what expression could represent the shaded region? So see if you can write that. All right, so I recognize that it was two circles, and the expression that I wrote is that the area of the shaded region is going to be the area of the big circle minus the area of the small circle. All right, so see if you can find the area of both shapes. So see if you can find the area of the big circle and the area of the small circle. Alright, so for the big circle, you should have gotten 256 pi, and for the small circle, you should have gotten 64 pi. So then my last question is, what is the area of the shaded region? So I'm going to go back to that original expression that I wrote. Area of the shaded is the area of the big, which is 256 pi, minus the area of the small, which is 64 pi. And I know that 256 minus 64 is 192 pi. So I always want to leave it in terms of pi first. And then 192 pi is equal to 603.19 centimeters squared. Alright, so go ahead and try number 9, see how far you can get, and see if you can figure out the area of the shaded region. Alright, so for this one I ended up with 55.85 units squared. So let's go ahead and walk through that. If you got that, you can move on. If you didn't, I will walk you through it. Alright, so first of all, what shapes make up the figure? Well, I have a big sector, I have a big piece of pie, and then I have a little piece of pie. So what expression could represent the shaded region? The area of the shaded could be the area of the big sector minus the area of the small sector. So big sector minus the small sector. So then what is the area of each shape? So the area of the big sector is going to be what percent of the circle, so 40 out of 360, times radius pi r squared, times the whole area of the circle. So when I got this, I ended up with 0.11111 repeating. So I ended up using that true value times 196, which I got by 14 squared. So I got 0.111 repeating times 196, and I ended up with a crazy decimal. So what I did is, to keep everything very accurate, is I put that as a fraction. So that value I just put in as a fraction, and I got 196 pi over 9. So that's the value I found for the area of the big sector. So then the area of the small sector is what percent, and because it's still the same angle, that angle doesn't change. So when we dilate an image, the angle doesn't change. So the area of the small sector is going to be 40 out of 360 times pi r squared. And so my radius for the small piece is 6. So it'll be 0.11111 times 36 pi, which I got by 6 squared. And so again, I kept that true decimal times 36, and I got 4 pi. So what is the area of the shaded region? It is going to be 196 pi over 9 minus 4 pi, and I just typed that into my calculator, and I got 55.85 units squared.